The danger of sudden explosive eruptions, phreatic explosions, the intrusion of cold, wet material into hot magma sets off an extremely dangerous physical phenomenon. The moisture present in waste, which is very high in household waste, upon contact with magma exceeding 1,000 degrees Celsius, instantaneously and explosively converts to water vapor. This sudden phase transition increases the volume of the material by up to 1,700 times, creating a massive pressurized steam explosion known as a phreatic eruption. Such an explosion is not only unpredictable, but it is also capable of hurling massive pieces of rock and lava kilometers away and releasing toxic clouds of ash and gas into the atmosphere. Dumping waste on an industrial scale exponentially intensifies this process and can trigger an artificial, uncontrollable eruption. The consequences of this would be catastrophic for all nearby residents and the environment, the logistical nightmare and impracticality of the supply chain. The enormous volume of waste produced annually, 239 million tons from just one country alone, creates an unimaginable logistical challenge on its own. The number of active volcanoes with stable lava lakes suitable for this purpose does not even reach the fingers of one hand worldwide, and they are mostly located in extremely remote and inaccessible areas. Transporting this amount of waste to these locations would require establishing a massive transportation network consisting of thousands of trucks, dedicated railway lines, and perhaps even an air fleet, all of which would have to operate in an environment with air polluted by toxic gases and frequent earthquakes. The financial cost and energy consumption required to build and maintain such infrastructure are so staggering that they invalidate any economic justification. And from a technical standpoint, it is unachievable in the real world. Unprecedented air pollution and long-range toxic plume emissions. Burning municipal waste in a volcano creates a giant, uncontrollable chemical reactor that will release an unprecedented combination of the most dangerous pollutants known to man. The combustion of plastics leads to the production of dioxins and highly carcinogenic furans, while the burning of heavy metals and electronic waste, such as lead, mercury, cadmium, and arsenic, causes these metals to vaporize and enter the atmosphere in gaseous or ultrafine particulate form. Unlike lava, which primarily has a local impact, these pollutants can be transported by atmospheric currents to other continents, leading to acid rain, widespread contamination of agricultural products, and global-scale health crises. In practice, rather than solving the problem, this action turns a local issue into a global catastrophe: the formation of an insulating crust and the prevention of efficient combustion. One of the main physical problems that is overlooked is the issue of density and buoyancy. Much human waste, particularly plastics, foams, and packaging materials, has a much lower density than molten rock. When these materials are dumped onto a lava lake, they quickly float to the surface and form a thick, continuous insulating layer. This layer acts like a blanket, preventing optimal heat transfer from the magma to the upper layers of waste. The result of this phenomenon is incomplete combustion, the production of thick soot, and vast amounts of partially burned materials and persistent organic pollutants. Instead of being destroyed, these pollutants are only concentrated in the environment or scattered over a wide area due to intermittent explosions, making the problem far more complex than before. Irreversible contamination of soil and groundwater. The long-term consequences of this action extend far beyond air pollution. Ash from the incomplete combustion of waste, which contains very high concentrations of heavy metals, salts, and toxic chemicals, will settle on the slopes of the volcano and surrounding areas. Subsequently, acid rain, which itself results from the dissolution of released SO2 and NOx gases in atmospheric moisture, will wash these toxic ashes and seep deep into the soil. These pollutants will eventually reach groundwater aquifers, contaminating them and rendering them unusable for decades, if not centuries. Cleaning up such widespread and deep contamination is nearly impossible and seriously jeopardizes the health of present and future generations. Astronomical economic costs and lack of justification. Implementing such a project would require a budget on the scale of the gross domestic product of large nations. The costs are not limited to transportation alone, but also include the construction of massive power plants to supply electricity for operations in remote areas, building roads and railway lines on rugged and unstable terrain, hiring and equipping thousands of workers with very high salaries to work in a lethal environment, as well as insurance costs and compensation for inevitable damages caused by accidents. In contrast, the costs of recycling and waste management through conventional methods, even on a large scale, are far lower and more cost-effective, ultimately benefiting both the economy and society. The destruction of pristine and unique ecosystems. Volcanoes and their surrounding areas often host unique and fragile ecosystems, home to specific plant and animal species that have adapted to the harsh conditions of these environments. The construction of massive infrastructure, roads, railways, storage facilities, in these pristine areas would in itself lead to the destruction of these habitats. Furthermore, the leakage of pollutants, the spillage of toxic materials, and changes in soil and water chemistry would completely eradicate the remnants of these valuable ecosystems, causing the extinction of species we have not yet even managed to identify. This loss of biodiversity is irreversible. The chemical resistance of certain materials to magma's heat. The assumption that magma destroys everything is a dangerous oversimplification. Certain human-made materials, such as some advanced ceramics, specialized glasses, and especially refractory metals like tungsten and molybdenum, have melting points higher than the typical temperature of magma, 700 to 1200 degrees Celsius. For example, tungsten has a melting point of 3,422 degrees Celsius. These materials do not melt in magma and remain solid, either floating within it or settling at the bottom. Ultimately, these resistant materials, along with other pollutants, alter the chemical composition of the magma and may unpredictably change its behavior in future eruptions, altering the behavior and dynamics of a volcano. Injecting a massive volume of foreign material waste into a magma chamber is an unnatural intervention in a highly complex and sensitive system. This action can alter the viscosity, chemical composition, gas content, and ultimately the overall pressure of the system. These changes could completely transform the pattern of the volcano's future eruptions. For example, turning it from a calm shield volcano into an explosive and dangerous one. We do not have sufficient knowledge to accurately predict these changes, and therefore, this act is like playing Russian roulette with an angry force of nature. Ethical and international issues. Volcanoes are often located within the territories of specific countries, but the consequences of pollution from this practice, toxic clouds, acid rain, do not recognize political borders. Forcing or persuading a host country to accept the world's waste presents an enormous political and ethical challenge. This practice could become a new form of environmental colonialism, where wealthy nations use money to pressure poorer host countries with volcanoes into accepting their waste, while the health and environmental consequences are borne by local and regional populations. This represents a clear injustice, both intergenerational and international. Immediate dangers to labor and local communities. Any attempt to carry out this operation would expose thousands of workers to one of the most hostile environments on Earth. These individuals would face constant exposure to toxic gases, such as sulfur dioxide, hydrogen sulfide, hydrochloric acid, the risk of severe burns, sudden ground collapses, unexpected explosions, and falling rocks. Ensuring the safety and health of these workers under such conditions would be nearly impossible and would result in extremely high human casualties. Furthermore, indigenous communities living on the slopes of these volcanoes would be the first victims of any mistake or accident, and their rights would be completely disregarded, squandering valuable resources and diverting from a circular economy. Incinerating waste in a volcano means the permanent destruction of all valuable raw materials that required significant energy and natural resources to extract and process. This practice directly contradicts the philosophy of a circular economy and recycling. Materials such as metals, certain plastics, glass, and paper can be recycled and reused repeatedly, reducing the need for new resource extraction and further energy consumption. Destroying these materials in a volcano represents an enormous waste of Earth's finite resources and perpetuates an unsustainable linear take-make-dispose system. Intense greenhouse gas emissions and the aggravation of climate change. Although volcanoes naturally emit CO2, burning organic and plastic waste, which are derived from fossil fuels, releases massive amounts of additional carbon dioxide into the atmosphere. Furthermore, this process releases more potent greenhouse gases, such as methane, from incomplete combustion, as well as black carbon particles, soot, which significantly contribute to global warming. Therefore, this idea is not only not a solution, but also directly exacerbates the climate change crisis and moves us further away from our carbon reduction goals. The impossibility of monitoring and controlling the process. A modern incineration system on the ground features advanced pollution control systems, filters, and real-time monitoring. In contrast, dumping waste into a volcano is entirely uncontrollable and unmonitorable. There is no way to accurately measure the temperature, the composition of emitted gases, or the combustion efficiency. This practice is a black box where the input and output materials are entirely uncertain, and we have no control over the final outcome. This approach fundamentally contradicts every engineering and scientific principle of waste management, creating a dangerous and flawed behavioral pattern. Accepting the idea that we can dump our waste into a bottomless pit and forget about it promotes a highly harmful and irresponsible behavioral model. This mindset eliminates the incentive to reduce waste production at the source, innovate in designing recyclable products, and invest in real recycling infrastructure. It is an imaginary escape that distracts us from addressing the root of the problem: unsustainable consumption patterns and flawed waste management systems. The only real solution is to take responsibility and seek solutions within the framework of a circular economy.